need more summary statistics. We need the percentiles, for instance. Percentiles are ways to describe the data that mimics a lot the median, the same line of thinking as the median, but just more general. Because the median sort of splits the data into two equal parts. Equal means half of the data is below, the other half of the data is above. So the median is a 50% percentile, a 50 percentile actually. So the median is a percentile. However, we could maybe get the idea to split the data in different ways. For instance, in quartiles. Why don't we, as a descriptive measure, tell what is the 25 percentile? What is the data point that has 25% below and 75% above? That's also a feature of the data. We could tell what that is. And in a way, we could even be more detailed. We could tell what is the 10 percentile? I mean, where do I have 10% below and 90% above? And then we have the extreme ones. What do you think they are? Let's find out about that later. What do you think the 0 percentile is? The minimum. Because yeah, the 0 might not be, it might be positive data anyway. So 0 is the minimum data point, 100% is the maximum data point. So that equals minimum and maximum actually. Let's define it formally. This is the definition from the book. We can define a percentile for any choice of percentage, proportion you want. And actually there's a bit of wording here. Don't worry about it, it's the same thing. Sometimes we talk about the 0.75 quantile, that's the other word, or we say it's the 75th percentile, right? So we have both the words quantiles and percentiles. They basically mean the same thing. It's just a matter of whether you talk about the percentage or the proportion, right? So it's just the wording. It's just one concept here. So in daily speech, percentile and quantile are two words for the same thing. And you meet both of them out there, so we like to have both of them in here. What you do is the same thing like the median. Here we order all of them. This is the mathematical notation for ordering, if you want, with such a parenthesis. x1 up to xn. We compute Pn. Well, if n is 100 and we are going to find the median, what would Pn be? 0.5 times 100, that would be 50, right? So we should choose the 50th observation. That's the idea of this Pn. But that can be used for any P or any n, right? The same line of thinking. Then we have to distinguish, like with the median. Either the Pn becomes an integer or not. Sometimes one, sometimes the other. We need a distinction in the definition to have something that copes with everything. If it's an integer, you take the average of the one you computed and the next one. And if you check, that matches exactly my definition of the median, this way of saying it. If it's not an integer, you take the next one in the list. So if it's 2.35, I take number 3. Right? Easy rule, actually. And the mathematics for that, it's not extremely important, but there is a mathematical way of expressing what is known as the ceiling of a number, the smallest integer larger than the number. That's technicalities. The concept of it, I hope, is pretty straightforward. I should say, when we start to do the R thing, the software thing, and we have some comments on that here, unfortunately, but that's life, this is only one out of at least 7 or 9 definitions, procedures out there. This is not the one and only true definition of a quantile. It could be defined differently. This is, in R you will learn, this is type equal 2. It's not even the default. We bring it here because it's nice and simple. And it's, by all means, it's just as good as all the other ones. It's just, here we have a concept that is not uniquely defined. I'm sorry. That's how it is. The mean is uniquely defined. The median, Quantiles are not uniquely defined. They can be defined in different ways. I'm sorry, that's life. But don't worry, I don't change the definition of the mean. That's what it is. At least if it's a usual mean. Should we try again? A little example. Same example as before. Now, actually, I know this could be a question in elementary school exam. Definition of quartiles is given. Median, at least, is given at elementary school. So I'm not. It's not to put you down. It's just to tell you, don't be scared about this. We are still on safe grounds, right? Lower quartile. It has a name. It's called Q1. It was not on the slide, but actually, these are called Q1. This is called Q2, which is actually, I have to do this slow if it should work on me. Should reset some settings here. And then this one, 75 percentile, that's Q3. How to find Q1, 25 percentile, 0.25 quantile. We order the data first thing. We compute NP, which is 5 times P. I mean, finding quantiles for very small data sets like this is almost ridiculous, because they don't serve a very descriptive role for such silly small data. But if I have 1 million data points, it can be worthwhile. And then we ask the computer to do the job for us, and not by hand, of course. 1.25, the rule would say, go to the next one, which would be number 2 in the row, in the sequence, right? So Q1 becomes 182. Upper quartile, 5 times 0.75. P would be 0.75. We should take number 4, right? That's how it is. Now we can deal with any N and any P here. You were out running yesterday. Good job.